we humans have always been drawn to the water's edge. It's no coincidence that civilizations throughout history have sprung up around rivers and coastlines. Water, you see, is more than just a pretty sight. It's fundamental to life as we know it. But what if I told you that our planet, as awash with water as it is, might not be the only one harboring vast oceans? What if, scattered across the cosmos, there are countless other worlds where liquid water flows, potentially teeming with life as we've only dared to imagine? That's the journey we're embarking on today, my friends. We're diving headfirst into the search for alien oceans, exploring the moons, exoplanets, and even interstellar clouds that hold the tantalizing promise of liquid water beyond Earth. Fasten your seatbelts, folks. It's going to be one cosmic swim. Our first stop is Jupiter's moon Europa, about the size of our moon. Beneath its icy crust lies a massive subsurface ocean. This ocean may contain twice the water of Earth's oceans. Jupiter's gravity generates heat, keeping the water liquid. This makes the possibility of life incredibly intriguing. But wait, there's more. Remember those tidal forces we talked about? They're not just warming up Europa's ocean. They're also likely creating hydrothermal vents on its seafloor, similar to those found in the depths of our own oceans. These hydrothermal vents are like underwater geysers, spewing out heat and chemicals from Europa's interior. On Earth, these vents are teeming with life, supporting entire ecosystems that thrive in the absence of sunlight. So, imagine the possibilities on Europa. Could these hydrothermal vents be harboring alien life forms completely independent of the sun's energy? It's a question that keeps astrobiologists up at night. And here's the kicker. NASA is planning to send a spacecraft called Europa Clipper to this intriguing moon in the coming years. This mission will allow us to study Europa's ocean in greater detail, searching for signs of life and perhaps even catching a glimpse of those elusive hydrothermal vents. Who knows what wonders await us beneath the ice of Europa? Our next destination takes us to another moon, but this time it's orbiting the ringed giant, Saturn. Say hello to Enceladus, a small, icy world that's no bigger than the state of Arizona. But don't let its size fool you. This tiny moon packs a punch when it comes to astrobiological potential. You see, Enceladus is a bit of a show-off. It's famous for its spectacular geysers, which erupt from its south polar region, spewing plumes of water vapor and icy particles hundreds of kilometers into space. Imagine that, a moon with its own built-in water fountains. But these aren't just any ordinary geysers. They're a direct pipeline to Enceladus' hidden ocean, which lies beneath its icy shell. Think of it like a cosmic soda bottle, shaken up by Saturn's gravity until it bursts open, sending a refreshing spray of ocean water into space. And what's even more exciting is that we've actually tasted these plumes. Well, not literally tasted, but our spacecraft have flown through them and analyzed their composition. And guess what they found? Water vapor, for sure, but also organic molecules, salts, and even traces of hydrogen. Now, hydrogen is a big deal because it's a key ingredient for a process called methanogenesis, which some scientists believe could be a potential energy source for life in Enceladus's ocean. It's like Enceladus is sending us a cosmic care package filled with all the ingredients we need to start thinking about the possibility of life beyond Earth. Talk about a warm welcome. The Cassini spacecraft, which orbited Saturn for over a decade, made multiple flybys of Enceladus, collecting valuable data on these plumes. Thanks to Cassini, we now have a much better understanding of this intriguing moon and its potential for harboring life. Enceladus has shown us that even small, seemingly insignificant worlds can hold big surprises. And with its active geysers providing a window into its hidden ocean, this little moon has become a prime target in our search for life beyond Earth. Titan, Saturn's largest moon, fires up the imagination. Instead of water, Titan has seas and lakes of liquid methane and ethane. Hydrocarbon rain carves channels through its alien landscape. It's like science fiction, but it's real. Titan's dynamic methane seas and cryovolcanoes intrigue us. But Titan's story doesn't end with its surface seas. Beneath that thick, hazy atmosphere, scientists believe, lies another secret: a subsurface ocean. This ocean is thought to be composed of water mixed with ammonia. Tidal forces from Saturn keep it liquid. This expands our understanding of where life could exist. Ganymede, the largest moon in our solar system, even bigger than Mercury, demands our attention. It boasts its own magnetic field, creating auroras like Earth's northern lights. Beneath its icy shell lies a vast subsurface ocean. Data from spacecraft like Galileo confirms this hidden water world. Now, we're not talking about a pristine freshwater ocean here. The ocean on Ganymede is likely a salty brine, perhaps even saltier than Earth's oceans. This saltiness keeps the ocean liquid despite intense pressures and frigid temperatures. An ocean trapped beneath miles of ice, churned by Jupiter's gravitational pull. It's an environment that's both alien and strangely familiar, reminiscent of hidden lakes beneath Antarctica's ice, harboring unique life forms. Ganymede's ocean propels it to the forefront of the search for life beyond Earth. Our solar system is full of surprises, with exciting discoveries we least expect. Ganymede stands out as a beacon of possibility, showcasing the universe's boundless capacity to amaze. Callisto, the outermost of Jupiter's 4 largest moons, often gets overlooked. It lacks the volcanic fury of Io, the spectacular geysers of Europa, or the magnetic personality of Ganymede. But don't let its seemingly quiet demeanor fool you. Callisto holds secrets whispered over billions of years. Callisto is the most heavily cratered object in our solar system. Its surface is a canvas of cosmic impacts, a testament to the violent early days of our solar system. Each crater tells a story of collisions and cataclysmic events that shaped this ancient world. But beneath this battered surface, scientists believe, lies a hidden treasure, a subsurface ocean. This ocean, like those on Europa and Ganymede, is thought to be a salty brine, shielded from the harshness of space by a thick, icy shell. Now, what makes Callisto particularly intriguing is its relatively low radiation environment. Unlike Europa, which is bombarded by radiation from Jupiter, Callisto offers a more hospitable environment for potential life, at least in theory. Callisto's lower radiation makes it an attractive target for future missions. Imagine sending a probe to explore its hidden ocean. It would be like diving into a time capsule. Who knows what we might find? Perhaps simple organisms around hydrothermal vents, or maybe something more complex. The possibilities are vast and mysterious. Callisto may not be flashy, but its potential for life makes it compelling. Sometimes the greatest discoveries are hiding in plain sight. As we explore space, let us not forget these quieter corners. Are we alone? Our search for alien oceans has kept us within our solar system, but it's time to broaden our horizons. Let's start with our nearest stellar neighbor, Proxima Centauri. Proxima Centauri b, or Proxima b, is an exoplanet orbiting a red dwarf star just 4.2 light-years away. It's a super-Earth, more massive than our planet. Intriguingly, Proxima b sits within the habitable zone. This Goldilocks region is where conditions are just right for liquid water. However, we haven't observed Proxima b's atmosphere yet. Now you might be thinking, hold on Neil, a red dwarf star? Aren't those known for being a bit temperamental? And you'd be right. Red dwarfs are known for their intense flares, bursts of radiation that could potentially strip away a planet's atmosphere. But science is full of surprises. Proxima b's chances of harboring life depend on its magnetic field. A strong magnetic field could deflect harmful flares. Much like Earth's magnetic field protects us. We need more data. And that's where the James Webb Space Telescope comes in. Our next stop is Kepler-22b, about 600 light-years away in the constellation of Cygnus. Orbiting a star like our Sun, Kepler-22b is a super-Earth, 2.4 times Earth's radius. It's in the habitable zone, potentially with liquid water. But its composition remains a mystery. Is it rocky or a gas giant? We don't know yet. If it's a gas giant, finding water is as likely as a penguin in a sauna. But let's be optimistic for a moment. Let's imagine that Kepler-22b is a rocky planet with a suitable atmosphere. It could be an ocean world, a planet completely covered in water. Imagine an endless expanse of blue, no continents, no islands. A mind-boggling concept, raising questions about life in such an environment. We're far from confirming if Kepler-22b is an ocean world. The Kepler Space Telescope detects planets by observing star dimming. To unlock Kepler-22b's secrets, we need to study its atmosphere, mass, and density. The James Webb Space Telescope will help us probe exoplanet atmospheres. With advanced capabilities, we'll search for signs of life like never before. Our search for alien oceans has taken us to planets hundreds of light-years away. Now prepare to be amazed by the TRAPPIST-1 system, home to 7 Earth-sized planets. 3 of these planets orbit within the habitable zone, potentially hosting liquid water. Now that's what I call a cosmic jackpot. The TRAPPIST-1 system is a treasure trove for astrobiologists. These planets offer a unique opportunity to study the diversity of planetary systems. With the James Webb Space Telescope, we're poised to learn more. Who knows what wonders await us in the cosmos? So far, we've journeyed to the moons of giant planets, those tantalizing worlds right here in our cosmic backyard. But the search for water, the cosmic elixir, extends far beyond our solar system. Imagine this: colossal clouds of gas and dust, light-years across, drifting through the vast expanse of interstellar space. These aren't just any clouds, my friends. These are interstellar nurseries, the birthplace of stars and planets, and guess what they're filled with? You got it, water. Now, I'm not talking about liquid oceans here. We're talking about water in its most basic forms, ice frozen solid in the depths of these clouds, and water vapor swirling among the cosmic dust. These interstellar reservoirs are absolutely massive, dwarfing the water content of all our oceans combined. Think about it. The water we drink, the water that makes up most of our bodies, it all came from somewhere. And that somewhere is the vast expanse of space. These interstellar clouds, these cosmic water towers, are constantly collapsing and churning, giving birth to new stars and planetary systems. As these systems form, they draw in the surrounding material, including, you guessed it, water. So when you think about it, the water that sustains us, the very essence of life as we know it, is literally star stuff, forged in the hearts of dying stars and carried across the universe on the winds of cosmic creation. And it's not just water. These clouds are also teeming with other organic molecules, the building blocks of life itself. It's enough to make you realize that we are all connected, not just to each other, but to the universe itself, through this cosmic cycle of water and life. We've explored planets orbiting distant stars, but what about the moons around those planets? Hold on to your telescopes, folks, because we're diving into the realm of exomoons. These celestial bodies, shrouded in mystery, are still largely hidden from our view. But just like the moons in our own solar system, exomoons have the potential to harbor vast oceans beneath their surfaces, hidden from the prying eyes of telescopes. Imagine a moon larger than Earth, locked in orbit around a gas giant, bathed in the warm glow of its parent star. Could such a world exist? It's not just possible, it's probable. Scientists believe that exomoons, especially those orbiting within a star's habitable zone, could possess all the right conditions for liquid water to exist. Now, finding these exomoons, these hidden ocean worlds, is no easy feat. It's like trying to spot a firefly next to a spotlight from across the galaxy. But astronomers are developing ingenious techniques to detect these elusive objects. By carefully observing the light from distant stars as planets pass in front, they can look for tiny wobbles and dips that might betray the presence of an orbiting moon. And what secrets might these exomoons hold? Could they harbor life more bizarre and wondrous than anything we've ever imagined? The possibilities are truly mind-boggling. As we continue to explore the cosmos, we must remember that the search for life beyond Earth might not just lead us to new planets, but to new moons as well. These hidden gems, tucked away in the vastness of space, could hold the key to unlocking some of the universe's greatest secrets. From the icy moons of our solar system to the swirling clouds of interstellar space, the search for water is a journey that takes us to the very edge of human understanding. We've encountered planets awash in global oceans, moons spewing plumes of water vapor into space, and even vast reservoirs of cosmic ice, the raw material for future worlds. It's a humbling reminder that we are not alone in the universe. Oceans across the galaxy expand the possibilities for life, giving us new worlds to explore and study. Missions like Europa Clipper, Dragonfly to Titan, and the James Webb Space Telescope will continue to unravel these mysteries, pushing the boundaries of what we know about water and life in the universe. Stay curious, because the next big discovery could be just beneath the surface of an alien ocean.